Hello, so today we will study about function templates in C++, in which function templates gives us the power to write a generic function. That means that the type could be anything, the type of arguments and the return type could be anything, and then you have to write just one definition of a function. The function templates come into a picture when the algorithm remains same, the logic remains same, so the operations or the line of code remains same on whatever type you just pass into that functions. For example, here we have this add function that takes two integers and it's just summing it up, it's just applying the plus operation to it and just it's returning the sum. So now if I now want to perform add function, if I want to call an add function on strings or on double or any other user defined data type, then I have to rewrite this add function with those arguments. Okay, so if I want to call an add upon strings, then of course I have to write one more add which takes two string arguments, and then it would work. Okay, otherwise if with this function only, with this function definition, if I want to achieve like something like this, say std string concatenated string, and if I want to write it like this, add, and say I want to add these two strings, s1 abc and std string s2 equal to xyz. So say if I want to add these two strings, okay, and I want to perform and I want to pass it into this add function. So if I do it like this, s1 comma s2, and I want to perform these operations, then of course this gonna give me error because I have not defined an add with type string. So what can I do? I can just do it like this. I can just change it to type here. Okay, and here also I have to change the type here. So now this would run fine. So if you want to know the result, needed string is this. So now if I run it, so you see that when I add two integers, this function definition was processed, and when I call this add with these two, with changing this type to string, then of course the concatenation would happen if I apply plus operator on the two strings, and that what happened here, that what give me the result here. And so that's why we have to remember that of course if you want to use another type here as an argument, then of course you have to rewrite this add function. Still your logic is same. So if your logic is same and you are rewriting those functions again, okay, so that's where the function templates comes into a picture. You just need to write one function, okay, and then it would work. The compiler would instantiate those function according to the types that you have called that function. So like what you can do is you just have to write here template type name t, and here replace the type with capital T here, replace it with T and replace it with T. So here also whatever, if this x and y would be string, then of course the result would be string, so that means it would also be T. So if it's be integer, then the sum gonna be integer as well, and then you are returning the type would again be same here. Okay, so what I have done, I have just written one generic function template here. Okay, so what the compiler will do with me, if I call an add with integer, the compiler would instantiate this template definition into a function that takes two integers. Okay, and then when I call add with string type, then the compiler would instantiate this add template with parameters and return type as string. Okay, and further, if I call add with other user defined data types or other data types, the compiler would do so. The compiler would not instantiate the function template with a type that you have not used or you have not compiled. That's called a type of a static polymorphism. Okay, so it's defined in a compile time, what definition, what instantiation, what instantiation of template is required. Okay, so now if I run it, so the same result that we have got earlier is being achieved here as well. Okay, so concatenated string is this and result is this. So you see, functional templates we can employ in places where the logic remains same, but yes, the types differ. The parameter, the past parameter types or the return type is differing. In that case, we can take in help of function templates, just called a static type polymorphism, because whatever types you use to call that function, the function with that type would be instantiated, and then the final exe would be out there. So this is what the function templates means. I hope you enjoyed the video. Do like and subscribe. Thank you.